Right. So, going through this homework post, button at the top right corner. Alright, so arithmetic sequence has first term, which is -4, and a common difference of 6. Write out the explicit order and use to find 101st term. So, what we were hoping, I guess, from what we've done in class, the formula that you are going to use was UN equals A plus n minus 1 lots of over d's. And we know from the work, the question, that that is the first term, so that is the A value, and the common difference is 6. So that's the D value. So when I'm doing a question like this, I always write those down, which is what I've seen a couple of you do. So A was -4, D is 6. So we put that into here. So UN equals -4 plus n minus 1 times 6, or so it's -4 plus 6 times n minus 1 if we're more used to seeing it written like that. Okay? Now actually, I've said here you don't need to do the multiply and bracket step, so that is a suitable answer. Simple as that. Alright. Make sense? Alright, I could leave it like that. But let's have a look. If I did expand it for those that gave that a go, we would have 6 lots of n, so -4 plus 6 lots of n is 6n, 6 lots of -1 is -6, okay? So then if we collect together, we've got, put the 6n first, the positive 6n, so 6n, but -4 -6, so we end up with 6n -4 -6 is? Minus. Okay? Yeah, if you like, or just -4 subtract 6. But we could do -4 plus -6, depending. Alright, either or, this is the step you didn't have to do. You could leave it like that in fact. The next part of it says, what's the 101st term? So, for the 101st term, we're looking for U101, which means n is 101. So if I put this into here, U101 is equal to -4 plus 6 times 101 minus 1. Yeah?
Yeah.
Because I've replaced n with 101. Done it there. N here, look, just the notation is 101. And then we just work that out. So 101 is, well, should we do it step by step? What would you do first?
-1.
Okay, is that 6 a 6? Sienna's shaking her head. I'm glad you understand this, but what is it if it's not a 6? Okay, it's 6 lots of n and 6 lots of the -1. So I can't add the -4 and the 6 together because the 6 is not really a 6 on its own. Does that make sense to you?
Yeah.
Yeah, that 6 is how many of these we have. So do you remember BODMAS?
Oh yeah.
So what do we do first?
Brackets.
Brackets. Okay, so let's do our brackets first. So -4 plus 6 lots of 101 minus 1 is
100.
100. Okay, so that's that bit done. What do we do next? Brackets, then it's. Do you do BODMAS or do we do
BEDMAS.
We do BEDMAS because that makes more sense. So that was brackets.
It's exponents.
That's exponents, good. Have we got any exponents to deal with? No. So we've done that, then it's
Division.
division. Have we got any division? No. Next is multiplication. Have we got any multiplication to be done? What? Exactly. 6 lots of 100. Yeah. 6 lots of 100. So what is 6 times 100?
So
So that would be 600 now. So we've done, there was no division, we've done our multiplication. The next stage is to do any
division.
addition or subtraction. And is there any of that to be done? The addition, so we've got -4 plus 600. £596. So just remind me what finding U101 is doing?
First.
Good. So the 101st term in the sequence is 596. Right, so we've done it using the formula method that I gave you yesterday. What was the other method that you might be happier with? We haven't done what we did before, yeah. So remember, I take you back to the question. It says an arithmetic sequence has a first term of negative and a common difference of 6. Now we are able to just put that into that formula that we've been given, but there is another way, right? Which was, okay, so we know that the first term, U1 is -4, and we know that D is 6. So we can actually write when N is 1, the number in the sequence is -4, yeah? What's the second, what's the third, what's the fourth, what's the fifth number in the sequence?
It's yeah.
2,
He said 8,
8,
14,
14,
and then 20.
20, and so on. And when it asks for U101, we're basically trying to go all the way up to 101. Now you have a choice. You could just keep writing that out until you get to the 101st. Why is that not an efficient method for your exams?
Takes way too long.
Yeah, exactly. Time is going to run out on something that we not worth a lot of marks. Okay, so we need to find an efficient method. So if I wrote it out like that instead, what would your process be? So here's my sequence. What have we done in the past to deal with those sequences? What do we do before we make a table? Because we don't always make tables.
Oh, you figure out what it goes.
And we kind of already know that anyway, don't we? Because what's it going to be? It's going to be +6, +6. How do I know? Well, you just used 6 to write those numbers, didn't we? So when I know it's +6, what do we do next? We can write that UN equals
6 minus
6n. Remember that, yeah? Take that number and it's that number of n's. But we want to know what the adjustment needs to be, if any. How do we figure out the adjustment that needs to happen to that? So we know that U1 equals, well, it's going to be 6 times 1, and that equals 6. But I want -4. Careful. So I'm at 6, but I want -4, so do you actually need to subtract how many? 10. So the adjustment is the subtract 10, so I need to put that there, yeah? Now, just to check, we had 6n minus 10 there. What did we have before? Well, we had this, but when we multiplied it out, we ended up with 6n minus 10. Okay, it's good that we get the same thing. Right. Now we need to figure out U101. What do we do? Yeah, so U101 is 6 times 101 subtract 10. So U101 is 606. We do the multiplication first. Minus 10. 606 minus 10 is? Which is lucky because that's the answer we got before, and if we got two different answers to the same question, we'd be struggling somewhere. But we didn't, we got the same answer. Okay. Let's talk this through quickly then. I think you've got that. I'm going to follow through Alistair's method first. So I believe he used the, well, if we've got un equals a plus n minus 1 lots of d, and then I saw him just write, well, that's un is, a is 3, and d is 7. So we've got 3 plus n minus 1 times 7, and I think you did put the 7 in front, didn't you? Which is good. Everyone happy with that? Yeah, we talked about that. It says in the question, write the explicit formula. That's the explicit formula. Don't need to go any further. He then said, well, therefore, you want U90. So U90 is 3 plus 7 lots of 90 minus 1. So that is 3 plus 7 times 89. That's slightly differently. 3 plus, what's 7 times 89, Alistair? 623. We then do U90 is 3 plus 623 is 626. So that's good. I am now going to go through the method that I saw Eden use straight away, which is if U1 is 3 and the common difference is 7, we can then do it's 3, then 10, then 17, then 24, then 31, and so on. But we don't need that, so because we know it's plus 7, it's going to be un equals 7n. We know that u1 is 7 times 1, which gives me 7, but I want 3. So my adjustment is minusing 4. This is where a couple of people with communication, I really should put that and write it here now. So I've got un 7n minus 4. Okay? No? As long as you've written that somewhere. I have to say, guys, this, what I've written, is not the best communication. Alright? But it's worked for us. There is something here that is kind of mathematically incorrect. Well, communication incorrect and mathematically, because I've said 7 equals 7, that's fine, but that 7 equals 7 minus 4, which is 3. So that's a lie, that's an incorrect statement. 7 does not equal 7 minus 4. That's not true, is it? So we do have to be careful of using our equal signs, but I've kind of done this as the process, that's why I've been using my different colours, but if you're happy with it, I'm just sort of making you aware of the kind of little grey area that I've introduced, but we're all good with it, right? So you've got to, I would say, to overcome this, we should write out the explicit rule in full, right? And then we're going to use it, right? So U90 is just then 7 times 90 minus 4. 7 times 90 is easier than the other way. So 7 times 9 is 63. Times by the 10, 630. Still minus the 4. And we end up with 626 again. Same answer. Yeah. No. So what you've done is you've made a mistake that didn't actually impact your final answer, I presume. So what I would be looking at in your, in your e-assessment, they may well look through that. Remember I said about filling out tables of numbers? So that would be that kind of process, and you may well lose a little bit of credit, not a lot, but a little bit for having those numbers wrong. But because you followed through, so what that means, Sienna, is you can see we don't actually need any of these numbers to get the right answer. We only needed the 7 and we needed the first number, didn't we? So we only wrote those out because that's what we have been doing, and it makes me feel comfortable to do it. You got them wrong and you still got the right answer. So that's just that something to do well.
What would it be?
Anyone got an answer for that? What if these numbers went down every time? What would you know? What's negative? So the D. The first term could be positive or negative and still go up or down, but the D is what makes it go down, right? How do you feel about it? Good? Want to do another one, or can we just do that? Alright, let's go back to the sheet we had. So remember we've got these examples. Alright, which we started with. So, looking back at your notes, what's the difference between an arithmetic sequence and a geometric sequence?
The number changes, the geometry. Or geometry.
No, that you're talking about the quadratic one, aren't you? That the adding changes each time. Remember I said we've done arithmetic and quadratic, and we were introducing geometric as a third option. Now it's in your notes on that page. Should see it somewhere. I wrote it down probably at the top. How do we continue a geometric one? Yeah, we're multiplying rather than adding. Okay, so let's look at this then. And we've also got a formula. Can you tell me the formula for a geometric one? In that pink box, we didn't write it down, but let's A. What's the explicit formula? AR to the power of n minus 1. So that's an exponent now. That's because, as you know, repeated multiplication is an exponent. What's repeated addition called? Multiplication. That's why we had 7 times n, because we added 7 lots of times. So when we have repeated multiplication, we have an exponent. Now, we're not going to go into as much detail because we're not as familiar with it. So let's use the formula this time. We don't have another option now. Let's use the formula. So the first term is 2. So A is 2. And it says the common ratio is 5. Now, we don't have a D now. What do we have instead?
R.
An R. Remember I said R was for ratio. So R is 5. Now, what does this mean? Well, our sequence would be, if I have n as 1, 2, 3, 4, 5, the first term is 2. What's the next term? Nope. How do you carry on a geometric sequence? You time. So this time it's going to be this number times
The ratio?
the ratio. Fine, good. So 2 times 5 is 10. 50. Careful. 250. Most. 4 lots of them make 1,000, so one more makes 1,250. Good. Alright, and we could carry that on. And we want, well, just the rule for the nth term. We're not asked to find any other particulars, so just the nth term. So we actually just need to put our numbers into here. Alright? So this is why we did go through the formula method before. So we're going to use these values and just plug it into this formula. Remember where this formula will be? Do you have to remember it, or is it provided? Provided. We provided somewhere in the year system types. Okay. So what's the formula? UN equals 2. When there's nothing between, that means it's times 5 to the power of. Done. It's not all of it. It's not the whole thing. It is for this question, but it's not. You need to know geometry. Okay. What I'm going to do is it says find the first term. Well, this helps me find any term. So the first term is when n equals what? First term is when n equals 1. So we are looking for u1. How do I find u1? Well, I put it into here, yeah? It's going to be 2 times -4 to the power of 1. Yeah? So what is that? Isn't it? 2 times -4 is negative. So there's the first term. Now to find the common ratio, that's what it goes up, like what we multiply by every time, yeah? So is it worth finding the second term and the third term to do that? But if I can find the second one, I can work out what I need to multiply by, yeah? So let's find u2. So u2 is 2 times -4 to the power of 2. Good. What's that? What's -4 to the power of 2? Remember your BEDMAS, brackets, exponents get done before multiplication. So we need to do this bit first. It's going to be 2 times, what's -4 squared?
Negative 16. Wait, no, it's regular 16.
Regular 16. Positive.
Yeah.
Because this is -4 times -4. Yeah?
Negative.
So that would be 2 times positive 16, and 2 times positive 16 is 32. Let's work out u3. You can do that. 2 times -4 to the power of 3. So we've got u3 is 2 times. It's actually negative 64, because you'll get negative 64. Yeah? Do you know you got positive, even though you put it in your calculator? So here's a tip. If I had my calculator, actually, I do have this calculator available. Now there is a problem. Do you remember your calculator is only as smart as what you tell it to do. It has no idea that if you tell it to do something you don't want it to do, it doesn't know that. So I don't know why my okay, because if I put in here 64 to so if I do 64 negative, wrong way around. Do you notice what my calculator does? I can't really see. So guys, on your calculator, you've got to be careful to put it in brackets. If you get sometimes it will give you the wrong answer. I'll try and do it with a screen. So we end up with U3 equals 2 times x6 gives you negative 128. Now, just to finish this question off then, we've got a sequence that is negative 8, then it's 32, then it's negative 128. What we're looking for is, what do we multiply by? And how do we work it out? So R is the common ratio, and I asked what ratio is. Ratio is a division. So to work out negative 8 times what gives me 32, well, what we do is we do 32 divided by negative 8. Or we do negative 128 divided by 32. Can you do both of those for me and tell me what you get? That's negative 4. This is also negative 4, which is good, because obviously it should always be negative or the same thing every time. So what's my common ratio? Negative 4. Now can I just ask you to do something for me? Can you look at the question again and see whether there's anything in the question that could have told you the common ratio without having to work it out? Says negative 4 in there, because do you remember when we did the, if I take you all the way back up here, it's A times R, A times R, and R is ratio. So that number will be your ratio. But it works out for yourself, and that's good. Okay. How do you feel about that? All right. So in the last couple, let me do this so I don't lose everything. Right. Let's do what's coming next. Where should we write it? You got space on the back sheet or something? Okay. So let's do a geometric sequence is given by UN equals 4 times 3 power of n. Write down first term and the common ratio. And find the 17th term.